Alright, so in this problem, I have 2 to the power of x minus 3 to the power of y is equal to 7. So I want to find the values of x and y. So for my solution, if I have something in the form 2 to the power of x minus 3 to the power of y is equal to 7, I'm going to rewrite 7 as 4 plus 3. So now I have 2 to the power of x minus 3 to the power of y is equal to 4 plus 3. And the reason I did this was because 4 is the same thing as 2 squared. So now I get 2 squared plus 3. And notice how I have something in the form 2 to the power of number minus 3 to the power of number is equal to 2 to the power of number. And I also have 3 to the power of 1. Now from here, I'm going to group the powers of 2 together and group the powers of 3 together. So I'm going to subtract 2 squared on both sides. So I get 2 to the power of x minus 2 squared minus 3 to the power of y is equal to 3. And then I'm going to add 3 to the power of y on both sides. So then these two cancel out, and I get 2 to the power of x minus 2 squared is equal to 3 to the power of y plus 3. Now, for my left-hand side, I'm going to factor out 2 squared. So, actually, instead, I should say I'm going to divide by 2 squared. So, 2 to the power of x divided by 2 squared is equal to, well, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So that's the same thing as 2 to the power of x minus 2. And then I have this minus 2 squared divided by 2 squared is 1. And now this is equal to, from on this side, I'm going to divide by 3. So I have 3 times 3 to the power of y divided by 3. 3 is the same thing as 3 to the power of 1. So I get 3 to the power of y minus 1. And then 3 divided by 3 is equal to 1. So I get plus 1. Now from here, if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 squared times 2 to the power of x minus 2, this is equal to 2 to the power of 2 plus x minus 2, and these two, and 2 and negative 2 cancel out, so I just get 2 to the power of x. So 2 squared times 2 to the power of x minus 2 is 2 to the power of x, and I have 2 squared times negative 1, which is negative 2 squared, and this is equal to 3 to the power of y plus 3. So I'm just checking if we distributed, or sorry, if we factored out right, and it looks like we did. So now going back here, let me rewrite this. I have 2 squared times 2 to the power of x minus 2 minus 1 is equal to 3 times 1 plus 3 to the power of y minus 1. And notice how 2 squared, that's equal to 4, is an even number, and 2 to the power of x minus 2, well, 2 to the power of any number is even, and an even number minus 1 is going to be odd. So we have an even number times an odd number is equal to 3 is an odd number, times 3 to the power of any number is an odd number, plus an odd number plus 1 is an even number. So you have an even number times an odd number is equal to an odd number times an even number. Now, what I'm going to do is I'm going to set the odd numbers equal to each other, and then the even numbers equal to each other. So this gives me two equations. I get 2 squared is equal to 1 plus 3 to the power of y minus 1. And I also have 2 to the power of x minus 2 minus 1 is equal to 3. So let's first start with this equation. this is going to equal 4 is equal to 1 plus 3 to the power of y minus 1, and this means that 3 is equal to 3 to the power of y minus 1, meaning y is equal to 2. So the value of y is 2. Now for 2 to the power of x minus 2 minus 1 equals 3, I'm going to first start by adding 1 on both sides. So I get 2 to the power of x minus 2 is equal to 4. And now 4 is the same thing as 2 squared, so I get 2 to the power of x minus 2 is equal to 2 squared. And this means that x minus 2 is equal to 2. And if I add 2 on both sides, these two cancel out, and I get x is equal to 2 plus 2, which is 4. So my solution is x equals 4, and y is equal to 2. Alright, so in this problem, I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So to solve this, I'm going to first start by rewriting 512. So 512, this is the same thing as 16 times 32. And now I can write this as 2 to the power of 3 to the power of 4 to the power of x is equal to 16 times 32. Now 16 is equal to 2 to the power of 4, and 32 is equal to 2 to the power of 5. So this is why we wrote 512 as 16 times 32, because now I have 2 to the power of 4 times 2 to the power of 5, and notice how we have another base of 2 over here, 2 to the power of 3 to the power of 4 to the power of x. So now I can rewrite this as 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5. Now all my terms are bases of 2. Now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So right here we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 4 times 2 to the power of 5, which is the same thing as 2 to the power of 4 plus 5. And 4 plus 5, that's equal to 9. So 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And also, instead of doing all that, remember over here how we had at the start 2 to the power of 3 to the power of 4 to the power of x equals 512. 512 is equal to, well, we know that 2 to the power of 5 is 32, so 512 is 2 to the power of 5 times 2 to the power of 4, which is 2 to the power of 9. So we could have just said at the start that 512 is equal to 2 to the power of 9, but some people don't know that 2 to the power of 9 is equal to 512, so that's why we had to do all of that. So now going back here, we have 2 to the power of 3 to the power of 4 to the power of x is equal to 2 to the power of 9. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So in this case, we can say that m is equal to 3 to the power of 4 to the power of x, and n is equal to 9. So because these two bases are the same, this means that 3 to the power of 4 to the power of x is equal to 9. Now, 9 is the same thing as 3 squared. So now I have 3 to the power of 4 to the power of x is equal to 3 squared. And now again, I can use this property because both my bases are the same. So this means that 4 to the power of x is equal to 2. And now 4 is the same thing as 2 squared. So I get 2 squared to the power of x is equal to 2. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x, which is 2 to the power of 2x. This is equal to 2. Now, I'm going to use this property again. 2 is the same thing as 2 to the power of 1, so then because these two bases are the same, I get 2x is equal to 1. And now, if I divide both sides by 2, these two cancel out, and I get x is equal to 1/2. So now, to check, my original equation was 2 to the power of 3 to the power of 4 to the power of x is equal to 512. So I have 2 to the power of 3 to the power of 4 to the power of x is equal to 512. And we said that x is equal to 1/2. So I have 2 to the power of 3 to the power of 4 to the power of 1/2 is equal to 512. Now, I'm going to work my way down from the top. So I first start with 4 to the power of 1/2. Now, 4 to the power of 1/2 is the same thing as the square root of 4. And the square root of 4 is equal to 2. Meaning I have 2 to the power of 3 to the power of 2 is equal to 512. Now from here, 3 to the power of 2 is equal to 9. So I have 2 to the power of 9 is equal to 512. And finally, 2 to the power of 9, that's equal to 512, as we already said at the start. So we get 512 is equal to 512.